In our next lesson, we're going to talk about systems and coin and mixture problems. So coin problems have to deal with money. Mixture problems are when you mix solutions of things. So let's start with a coin problem. So let's write the first example. All right, so here's our example. Jane has a collection of nickels and quarters worth $3.05. She has 7 more nickels than quarters. How many of each type does she have? Well, I'm going to let N be the number of nickels, and I'm going to let Q be the number of quarters. So first off, we know that she has 7 more nickels than quarters. So 7 more nickels than quarters means that the number of nickels has to be Q plus 7, because we have 7 more nickels than quarters. The number of nickels is the number of quarters plus 7. So when you do coin problems, we have to take into consideration what the value of the coins are. We know that the value of all of these coins are $3.05. Well, how do you get there? Well, we get there by taking the nickels, multiplying by 5 cents, and it's not 0.5, it's 0.05 nickels, plus 25 cents, or 0.25Q, equals 3.05. So now, this is easily set up for substitution. I'm going to take this, plug it in. So that gives me 0.05 multiplied by Q plus 7 plus 0.25Q equals $3.05. Now we just solve. Distribute the 0.05. And we just keep solving. And the last step, divide both sides by 30 cents. And that gives me Q equals 9. So that means the number of quarters is 9. Now, nickels. The number of nickels is the number of quarters plus 7. So that'd be 9 plus 7, and that would give me 16. So we would have 9 quarters and 16 nickels. All right, so let's start talking about our mixture problem. So the same method can be used for solving coin problems than we do with solving mixture problems. But we have to think through this. The mixture problems are harder. All right, so here we go. Number 2. A coffee wholesaler mixes Colombian coffee beans selling at $1.20 a pound with Venezuelan beans selling at $1.60 a pound. He wants a mixture of 90 pounds to sell at $1.24 a pound. How many of each pound should he use? So I'm going to let C be the number of pounds of Colombian beans. Make sure you understand it's pounds, not just beans. V is the number of pounds of Venezuelan beans. So we're going to start with the total. We know we want a total of 90 pounds. So we can start with the number of pounds of Colombian plus the number of pounds of Venezuelan equals 90. From there, we have to take the price. So we have $1.20 for Colombian plus $1.60 for Venezuelan. But what does that give us? Because we don't have the total cost. What'd I do? What do you think you'd do here? We know we want a mixture of 90 pounds to sell at $1.24 a pound. Well, what you'd have to do is, if we know we're going to have a total of 90 pounds at $1.24 a pound, we'd multiply them. And so we would get 90 times $1.24, which would give me $111.60. So now, we can solve this however you would like. You can use elimination, you can use substitution, which is what I'm going to use. So I'm going to solve for C and get 90 minus V. And I'm going to plug it in right there. So $1.20 times 90 minus V plus $1.60 V equals 111.6. So this would give me 108, I believe, minus 1.2 V plus 1.6 V equals 111.6. Okay, so I'm going to subtract the 108, and that gives me 8.6. And then 1.6v minus 1.2v gives me 0.4v. No, not 8.6. Sorry, that's wrong. Well, that's going to be 3.6. That's much better. We divide both sides by 0.4. V would be equal 9. So what does that mean? Well, that means we have 9. We always have to label 9 pounds. And if you wanted to actually write pounds, because that does look like 91, you can. And Colombian, then, if we want a total of 90, that would mean 9 pounds of Venezuelan and 81 pounds of Colombian. Let's look at example number 3. A 20% alcohol solution is mixed with a 30% alcohol solution to obtain 25 gallons of a 24% solution. How many gallons of each are needed? So in this problem, I'm going to let, let's do x and y. I'm going to let x be the number of gallons of the 20%, and y to be the number of gallons of 24%. So if we look at this, we then use the x and y to set up our equation. So let's start with the easy one. We know that the total number of gallons is 25. So that's going to be x plus y equals 25. So looking at that, we then have to write our second equation. This is where it becomes a little trickier, because what we want to think about, we got to think about what we're doing here. We're mixing a solution that's only 20% alcohol and 30% alcohol. We're mixing those together to give us a total of 25 gallons at 24%. So if I do 20%, that would give me 0.2x, and then 30% of our next gallon, or next solution, and that gives us a total of 25 multiplied by 24%, because we have 24% of the 25 gallons. That's our mixture. So we multiply that, and that would just be 25 times 0.24 would be 6. And there we go. So now you can use substitution, you can use elimination. Since everything is lined up, I'm going to use elimination by multiplying the second equation by -5. So the first equation remains the same. The second equation would be -1x, -5 times 0.3 would give me -1.5y equals -30. I combine the equations. That gives me -12y equals -5. If I divide this, I get y equals 10. So y equals 10. Well, total I have 25. So we know our answer is going to be 10 gallons and 15 gallons. But that's not enough to answer, because we have to tell what percent of each gallon we have. So this is why we look back at the beginning. We let x be the percent, that's 20%, and the y be the number of gallons at 24%. We solve y. Y was 10. Well, since y is 24%, we would say 10 gallons of the 30% solution and 15 gallons of the 20% solution.